Hi and welcome to this on maths prediction for the paper 6 higher tier maths GCSE. Enjoy! Hi, I'm Chris Gilpin and welcome to this prediction for the paper 3 maths paper. I hope paper 1 and 2 have gone well for you. And I'm not going to talk too much, but don't forget that these papers are on our website, onmaths.com, which I'm sure the link will come up there now. If you click on the link, it will take you to the prediction on our website. Don't forget that the prediction on our website changes the numbers in the questions, so you can do it as many times as you want, and you're not just getting the same answers each time. This video will go through all of the answers to a set of numbers. So if you don't understand a question, come to this video and you can see how to do it for maybe a different set of numbers, but you can get the methods. If you check out our website, we've got tutorials for everything. We've got topic busters, demon questions, practice papers, all sorts of things. So please check out our website on maths.com. If you enjoy this video, please click like. If you want to see any other stuff from us, especially over the next few days, please click subscribe. Thank you and enjoy the video. Okay, so this question's about exchange rates, and this part here is quite important. If I just rewrite that to make it a bit bigger, this is basically saying that to get from pounds to dollars, we just need to times by 1.42. And you can get that by just dividing the right hand side by the left hand side. Now 1.42 divided by 1 is just 1.42. So the problem with this question though is that it wants the answer in pounds, so we'll need to convert both of these things into pounds. So we're actually going the other way. When we go the other way, instead of times we just divide. So we're dividing both sides, or we're dividing dollars by 1.42 to get to pounds. So we've got $3,000 and we want to convert it into pounds. So we're going to divide it by 1.42, and I'm just going to type that into my calculator. So 3,000 divided by 1.42, and it's to the nearest pound 2112.6, and we'll round to 8. Obviously to 2 decimal places, because money is always to 2 decimal places. So it says also that that the laptop costs £2,500 in the UK, and how much cheaper is the laptop in the USA than the UK. So what we need to do now is we need to do £2,500, which is the price of the laptop in the UK. We're going to take away the £1,112.68, and on my calculator I'm just going to type in 2,500 take away answer and then press equals, and it gives me the answer of 387.32. so it's £387.32 cheaper. Okay, so to draw this graph, we're going to use our table of values, which is shown below. So when x equals 2, what I want to type into my calculator is 2 squared minus 2 plus 10. And it's exactly the same as the equation at the top, but instead of x, it's going to be 2. Now I can do this in my head. 2 squared is 4, 4 take away 2 is 2, and 2 plus 10 is 12. We're going to do this for the other one. So when x equals 1, we'll do 1 squared take away 1 plus 10. 1 squared is 1, so 1 take away 1 is 0, plus 10 is 10. Then when x is 0, just going to be 0 squared take away 0 plus 10, which is obviously going to be 10. Now when x is negative 1, we've got to be careful. If you type this into your calculator, make sure you put any negatives in brackets, otherwise it will get that wrong. So minus 1 squared is 1, If you don't put into brackets, the calculator will assume that it's -1, because it will square the 1 first and then put a minus before it. Minus minus make us a plus, so that's going to be 12. And when x is -2, it's going to be -2 squared minus -2 plus 10, which is 4 plus 2 plus 10. 4 plus 2 is 6, plus 10 is 16. Okay, let's plot this onto our graph. So it's 16, was it 12? 10, 10, and 12. Okay, so next we need to join these up. Now, there's a few rules for joining up a quadratic. It needs to be a U rather than a V. If you've got 2 points at the bottom, which we do, you need to make a point to go beneath them at the bottom of the curve, and it's got to be one line rather than feathering or a couple of lines, or oops, I've made a mistake, so I'll do it again. Okay, so I'm going to try my best here to join these up. I'm not fantastic at this, but should be alright. Now be careful here to go beneath those 2 points. Now up like that, and that should be fine. So it's this part here, you've just got to make a point to go beneath those 2 points. If you draw a line straight across, you will lose a mark. Okay, so we're asked to find the median number of people on the buses. Now, there are multiple methods to find the median. I'm just going to show one of them. Now, a formula that's really helpful for the median is to find the position of the median. You do n plus 1 over 2. Okay, so you work out how many there are in total, which we can do on a calculator. 1 plus 3 plus 4 plus 8 plus 13, which is just all the frequencies added together, which is 29. Add 1 to it and halve it. So that's going to be 30 divided by 2, which is 15. Now this gives us the position of the median, which is going to be useful. Something else I write on a table is the running total. So we're just going to do a running total, so it's only 1 in the first one. Then we're going to add the 3 there to get 4. Going to add the 4 there to get 8. Going to add the 8 there to get 16. And we're going to add the 13 there, and hopefully that should give us 29. Now, these numbers here, 16th and 29th, give us the largest number, the largest position in that section. So the first value is the biggest one in this second or this first group. The fourth value is the biggest one in this group. The 8th value is the biggest one in this group. The 16th value is the biggest one in this group. And finally the 29th value is the biggest one in that group. So we're looking for the 15th value. Now if the 8th value is the biggest one in the 4 people group, then the 15th value must be in the group with 5 people. So it must be in the group with 5 people. Now a few other ways you can do this is you can write out the numbers in one long list. That's easy for this question because there's only 29 values. I say it's easy, that would take you a while, but if in the exam there's 100 values, that's slightly harder to do it for. Another way of doing it is just having a look at the frequencies. There's 13 in this, and there's kind of 13 in kind of this bit here, so it's going to have to be in this group here. There's loads of different methods for this. The method I've just shown you now is definitely the most versatile method to use, so it's a good one to use if you haven't got a one that you are used to so far. Okay, so this question is a little bit more complicated than it first seems. So we've got Adrian, Ben and Charlie, and they share some sweets in the ratio of 6 to 3 to 8. And it says that Charlie got 12 more sweets than Adrian. Well, first of all, let's have a look and see how many more parts that Charlie... Ooh. Always cross my L's for some reason. Charlie got more than Adrian. Okay, so he got 8 take away 6 is 2. So he got 2 more parts. And so let's have a look and see what 1 part is worth. So those 2 parts equates to 12 more sweets. So we do 12 divided by 2, 6. So each part is worth 6 sweets. It says work out the total amount of sweets. So we need to work out how many parts there are in total. So we do 6 plus 3 plus 8. Now I know 6 plus 8 is 14, plus 3 is 17. So we've got 17 parts in total. Each of them is worth 6 sweets. So to work out the amount of sweets, we do 17 times 6. Now we could do 7 times 6, which is 42, 10 times 6, which is 60. So add the 2 together, it's 102. So there are 102 sweets altogether. Okay, so for this question, we're given a plan of a garden, and we're given a set of instructions of where the tree can be planted. So it says that we can't be any closer than 5 meters, so at least 5 meters away from point C. So that's from here. So let's have a look at that first. Now I'm going to find it very difficult to make this perfect because I can't draw circles or arcs on this. However, I'm going to try my best to show you roughly what it should look like when you do it on paper. So you need a compass for this, and with the compass you would measure out 5 centimeters, which I'm sure that's the scale of this. So you'd measure out whatever it says the scale would be. So for this one, I'm imagining 1 meter is 1 centimeter. And you would draw a kind of quarter circle with your point of your compass at C, and you draw like a quarter circle like that. And that's not too bad, although it looks it looks closer to B than it should be, but it's not too bad. Okay, so that's that first bit sorted. Now it says the tree must be closer to CD, which is this bit here. So it's got to be closer to this than AB, so than this. So what we need to do is ensure that it's closer to the red line than the green line. Now to do this, you need to do a perpendicular bisector of AD or BC. Either one would work. So you get your compass and put it at point A, and you measure out something that's more than 5 centimeters. It doesn't matter how much more. And you do an arc, like a bit of the circle this side and a bit of the circle this side. You do the same at D, and you do a bit of the circle this side and a bit of a circle this side, and then you join those up. So I'm going to join those up and just keep going like so. Now that will give you a perfect equidistant line from AB and CD. Mine's a little bit high, as you can see, but on your one it should look perfect. So it says shade the region the tree can be planted. So it's anywhere, and I might do a different colour for this so it just stands out a little bit. It's anywhere here. Now you always just double check this. So the blue shaded, and on your exam don't bother with a different colour, just use a pencil to shade it in. It says the tree must be at least 5 meters away from point C, which mine is, and the tree must be closer to CD than AB, which mine is. Okay, so we're asked to write 88 as a product of its prime factors. So the first thing to do is write 88, and then we have 2 shoots coming from it. Now I need to find out which 2 numbers times together to make 88. Now a little tip, if you've got an even number, always pick 2. So 2 times 44. Now whenever we get to a prime number, we always circle it, because that's finished. So 44, I can get another 2 out of that, we'll divide another 2 out of that, so 2 and 22, 2 and 11. Now 11 is also a prime number, and when you're left with just prime numbers, then you write your answer out like this. Now if you're also asked to write it in index form, that means instead of 2 times 2 times 2, you're going to write 2 to the power of 3 times 11. Now don't work that out because that will give you 88. So 2 cubed times 11 is 88. Okay, so we're given a regular polygon, so that's going to be quite an important word there. Regular means that all of the sides, angles, and exterior angles in this polygon are exactly the same. So if I added another one here, this would also be x. If I put another exterior angle here, all the way around this, they're all x. They're all the same, and there's 16 of them in total. Now the one thing we know about exterior angles is they always add up to 360. So to find out what that angle is, we just get 360 and we divide it by 16 because there's 16 identical exterior angles. So I get my calculator out. 360 divided by 16 equals, and it's 22.5. So we can check that. We can do 22.5 times 16 and it has to add up to 360, which it does. So inequalities, what are they? They just mean instead of x equaling something, x is greater than or smaller than something. So x can normally have lots of different values. Now, this statement here is really important. Integer just means a whole number. So we know that x can't be a half because that's not a whole number. Now, x says here x is greater than minus 7 and is less than or equal to 3. So when it asks you to write down all the numbers that that's true for, well, let's have a think. Well, if it's if it's greater than minus 7, then it can't be minus 7. It can't be equal to it. So it's going to be minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, and 2. Now let's have a look at the other one. It says x can be less than or equal to 3. So that line there, if you look at it, that little line there, so if I do it a little bit bigger, the line that I've just drawn there says it can be 3. So we must include 3 in our answer. And that's how you get full marks. Now you probably will get 1 mark if you forget to put the 3 down or you put the minus 7 accidentally. Right, the next one I'm just going to write out a little bit bigger. Now the way we do this question is the same way as solving just a normal equation with an equals, but don't ever put an equals. There was an exam a few years ago that if you wrote an equals in it, they would give you 0 marks. So the first step is to expand the brackets. So I do smiles and rainbows, but if you've got another method, that's fine. I'll put a little line there to remind me to times it. So 5 times 3x is 15x. And 5 times minus 5 is minus 25. Now that you could have divided both sides by 5 and that would have been fine. Next step is to get rid of this minus 25. And you must start with that. You can't get rid of the 15 first. So we're going to add 25 to both sides to get rid of that minus 25. So we're left with 15x on this side. And 35 plus 25 will be, well, 5 plus 35 is 40. 40 plus 20 is 60. Now to get rid of this times 15, we need to divide both sides by 15. So that will get rid of the 15 there. And how many 15s in 60? Well, 2 times 15 is 30, so it would be 4. Now be really careful not to accidentally put any equal signs in your answer, and especially this bit here. So it's x is greater than 4. So there's a lot of places to start with this question. Whenever I'm given a shape in a question like this, I always ask myself, well, do I need to work out the perimeter of it or the area? And sometimes you're going to have to figure out something else, but it's mainly going to be those two things. Well, this is all about covering the floor, so I'm imagining I'll need to work out the area. So I'm going to start off working out the area. Now to do that, I've got to work out what shape it is. Well, it's a trapezium because there's two parallel sides and it's four-sided. So if you've got a pair of parallel sides and it's four-sided, it's a trapezium. So to work out the area, the formula is half a plus b h. Now you need to work out what h and a and b are. A and b are always the ones on the parallel sides. So it's those two. It doesn't matter which way round you call them. H is always the one that connects the two at right angles. So half 2.5 plus 1.5 times 11.5. So I can get my calculator out and I can do 0.5 times brackets 2.5 plus 1.5 close brackets times 11.5, and that gives me the answer of 23. So the area of this is 23 meters squared. Okay, so I've managed to work that out. Let's have a look. So tiles are sold in packs, 25% off marked price, and they're marked at £12. So next thing we can work out is how much they actually cost. And it doesn't matter if you do this in a different order as long as you do each step and label it well. So cost of pack. Okay, so we've got £12 and we need to reduce it by 25%. Okay, so first of all I need to work out 25% of £12. So the way I can do that is just find a quarter of 12, so divide it by 4, so that's going to be £3. So the cost is going to be £12, take away my £3 discount, which is going to be £9. So the cost of the pack is £9. Okay, so it feels like we're getting somewhere. Now, if each one costs £9, but each one covers 2 meters squared, okay, so we know we've got 23 meters squared to cover. So what I can do is I can work out how many packs I need. So packs needed. So I've got 23 meters squared to cover, and each pack covers 2. So I'll do 23 divided by 2. Now that gives me the answer of 11.5. So I need 11.5 packs. Well, unfortunately, shops don't like you taking half a pack. Trust me, I've tried. They really don't like it. So you must always round this up. Otherwise you won't have enough. If you round it down, say if it came out as 11.4, if you rounded that down, you won't have enough. So there'll be a patch of untiled floor in your kitchen. That's not good. So the answer is going to be 12. So I need 12 packs. So total price. So I need 12 packs and each of them costs £9. So 12 times 9 is £108. So it's going to cost £108. Now, the last bit of the question, she says she's got £100 to spend. How much extra? So it wants it in pence as well. My goodness. So we need to do extra. And all I'm doing here is doing 108, take away 100, which equals £8, which is 800 pence. Okay, to convert from standard form, you just write the number down, and this here, the power, will tell you where to go. So if the power is positive, then you go to the right. If it's negative, then you jump to the left. Now since it's negative, we're going to jump to the left, and it's -6, so we're going to jump 6 spaces. So 1, 2, 3, 4, 5 and 6. So the decimal point will now be here, and you fill in all of the jumps with zeros. So one of the jumps is used by the 8, but all the other ones we fill in with zeros. And whenever you've got just a decimal point, you need to have something before it, so we put a 0 before it. So the answer will be 0.00000084. That would be the answer. So let's just count. There's 5 zeros and 5 zeros. Okay, to convert to standard form, you write out the number and you try and put a decimal place in to make the number between 1 and 10, but not including 10. So if I put it in here, that would be 72, so that would not be right. So I need to put it in here. Then you count how many times you had to move the decimal point to get it there. So the decimal point started at the end of the number, and we had to move it 1, 2, 3, 4, 5, 6. Okay, so the rule is that the number has to be between 1 and 10, which this one is. Now, if you had a big number, then the power of 10 will be positive. Now here we did have a big number, so it's going to be positive 6. On the previous one, we had a small number, 0.00084. I don't know if I said the amount of noughts that were there, and you can see that the power in the question was negative. So negative power of 10 is really small number, positive power of 10, really big number. This does turn up on the calculator paper as well. So if it does, you can actually just type in question A into your calculator and just write down the number it gives you. Now some calculators are smart and do things in standard form, so you might need to do it this method anyway. Whenever we see a 3D shape in a question, you've got to ask yourself, is the question asking for a volume or a surface area? And that should be the first question that goes into your mind. Yes, it might be asking for something else, but those are the main two. We're looking at this, we're filling the swimming pool with water, so it's going to be a volume question. Now, way of approaching this is figure out what the shape is. Well, the shape is a trapezium-based prism. So we've got to first of all work out what the area of the trapezium is. So I'm going to draw the trapezium out first. And that height is going to be 2.7 that side, 5.3 that side, and 25 across. And I'll leave off meters because I know they're all in meters. But do check they are all in meters when you do this. So we've got so first of all work out the area. Now the area of a trapezium is half A plus B H. Now A and B are always the two parallel sides, and then the height is the one that connects them at right angles. So the height is going to be 25 there. And all you're doing is working out the average of the two bases, the 2.7 and 5.3. We're going to times that by 25. Okay, so we'll crack our calculator out. 2.7. Some of you will probably see this straight away. So the first bit comes out as 4 because halfway between 2.7 and 5.3 is 4, and then times 25 is going to be 100. So the area is 100 meters squared. Now for a prism, so volume, all you need to do is work out the area of the cross section, which is this bit here, the bit we just worked out, and then times it by how 3D it is. I think they call that the length officially, 15 meters. So the volume is going to be 100 meters squared times 15, which is going to be 1,500 meters cubed. So that's what the volume is, and it says the machine transports the water at a rate of 20 meters cubed per minute. So in 1 minute it's going to be 20, in 2 minutes 40. The other way of working this out, or the other way of thinking about this, is how many 20s are there in 1,500? So we can say time equals, so this is how much it's got to fill, and this is how much it does per minute. So on the calculator, 1,500 divided by 20, which equals 75 minutes. So it's going to take 75 minutes to fill the pool. Okay, so this question is asking us to find unknown lengths. Now, the easiest way of approaching this question is to draw the two triangles, the little one and the big one, separately. So I'm going to do that really quickly. I'm going to draw the small one, and I'm going to draw the big one. There we go. And I'm going to fill in the length. So this small one has 37 here, and 17 at the bottom here. This big one has 50 down the side, and 34 at the bottom. Okay, now a second most important thing to realise with this question is that these two triangles are mathematically similar. The reason is that the top angle here is shared. These two here are both corresponding because they're off a parallel line, and it's the same with these two. And any two triangles that have exactly the same angles will always be similar, which means that one's an enlargement of the other. And with enlargements, we're always thinking about scale factors. So we've got to find out what you times 17 by to get to 34. So on my calculator, I do 34 divided by 17. I probably shouldn't need to do it on the calculator, because obviously the answer is 2. So if I'm timesing that side by 2, and I'm looking for length AD. Now AD is this one here. How do I get from 37 to AD? And remember, it's corresponding side, so it would be the left hand side will go to the left hand side. So I times that by 2. So it would be 37 times 2, which is going to be 74. So my answer will be 74. And the last one, let's do it in a different colour. Now we're looking for length CE. So CE is a bit of a weird one, isn't it? Because CE is this bit here. So all I need to do is work out what AC is, which is this one here. So let's work out what AC is. So to go from the big one to the small one, instead of timesing by the scale factor, I'm going to divide. So I'm going to divide it by 2. So AC is 25. Now if AC is 25 and the whole thing is 50, so let's try and make this a bit clearer. So the whole thing is 50 and AC is 25. So this bit up until this bit, then CE must be 25 as well, because it's 50 take away 25, which is 25. Okay, so to do this question, I'm going to start off with a number line, and I'm going to put the number given to us in the question in the middle, so 89.6. Now it says it's the nearest tenth of a second, so what I want to do on the left hand side is put the next number down. So what could it have rounded to if it was slightly less? Well, the next one down would have been 89.5, and the next one up on the other side would have been 89.7. Now to find the bounds, we just find the halfway points, and this left hand one will be the lower bound, the right hand one will be the upper bound. So that's going to be 89.55 and 89.65. Now it says it wants it as an error interval and use t for the time. So we put t in the middle, then we put the greater than sign on the left hand side, and then just the normal inequality on the right hand side. Now these two signs here will always be the same. Okay, so when you're asked to do an error interval, it's that way around. So we're going to do our 89.55 on the left hand side and 89.65 on the right hand side. Now the reason why the inequality has an equals underneath it on the left hand side is it can be 89.55 and still round to 89.6. The reason it doesn't have one on the right hand side is 89.65 would have rounded to 89.7. So if you just remember, the things in the blue circles are always that way, and the letter it asks you for, just put in the middle. If it doesn't ask you for a letter, you can just pick any letter you want. You can call it X or something. And then the lower bound is on the left hand side and the upper bound is on the right hand side, and the lower bound's always here and the upper bound's always here. This question asks us to factorize, which means put it into brackets. It's a quadratic because it has an x squared, an x and a number term. Now to do these, we first of all put two sets of brackets down if it's a quadratic. There's no number, well there is, it's 1, but there's no visible number before the x squared, so the first two things in the brackets is going to be x and x. Now to do this question, we need to think of two numbers that add together to make the 12 there, and times together to make the minus 45 there. So to do this, to find what those two numbers are, I'm going to find the factors of minus 45. So I could try 1 and 45, so let's have a think. I could have a positive 1 and a negative 45, that would make minus 44, or I could have a negative 1 and a positive 45, that would add together to make 44. Now we needed to get to that 12, so that's not going to get 12. So 2 doesn't work, there aren't any with 2. 3 and 15, let's have a think. Positive 3 and negative 15 would be minus 12, so if we have a positive 15 and a negative 3, that would add together to make the 12. So we'll have a negative 3 and a positive 15. And you can expand that to check that it works. And it doesn't matter which way around you put them. So I'm going to put my answer the other way around, like that. Now this question can seem a bit daunting because it's talking about bearings and yet doesn't give us a single angle. But whenever you are given a question on bearings and there's not an angle, then really you should be thinking, is this trigonometry? Now trigonometry is grade 5, so it's the hardest on the foundation paper and actually quite difficult on the higher paper as well. So let's have a look at how we use trigonometry with bearings. First thing to notice is what we're asked for in the question, where it says work out the bearing of Freetown from Gamley. So we are at Gamley and we're working out the bearing of Freetown. So we're going clockwise from north, so we're working out this angle here. Now we can't work out any of those angles on the right hand side really, but we can work out this angle here is 90 degrees, and the reason we know that is because it says the hiker walks west, and the angle between north and west is 90 degrees. So we know we've got 90 there, and if we knew this one here, then we could add it to 90 degrees and take it away from 360 to work out the green bearing. So it's this red angle that we're looking for, which I'm going to call x. So we go use trigonometry. So first step with trig is to label the sides. Well, the marked angle is the x, so the opposite here, and we've got the adjacent here, because we've got the 90 degrees here, because the angle between west and south is 90 degrees, and we've got the hypotenuse here, which we don't need. Then I do my SOHCAHTOA, and it's obviously going to be TOA that we're going to use. So we draw our TOA triangle. So tan, the angle, which is x, equals, and then we've got the opposite, which is 50, over the adjacent, which is 65. Now whenever you've got tan x equals, what we need to do is we need to inverse tan both sides. Let's make sure I put my lines in. Inverse tan both sides, and so we get x equals inverse tan of 50 over 65. And we've got loads of videos on trigonometry, so if you're watching this not really understanding what we're doing, then maybe have a look at some of those videos. I'm going to type that into my calculator, and it says x equals 37.568, blah blah blah. Okay, so we're going to add that to the 90 degrees, and we're going to take it away from 360, so we'll write that down. So 360 take away the 90 plus 37.5685, blah blah blah. Okay, so I'm going to type in 360 minus brackets 90 plus answer, close brackets. And it gives me the answer of 232.431 blah blah blah. And I'm going to just write that down as it says to in this whole number, so it's going to be 232 degrees as my bearing. And the last thing is just check that that makes sense. Well, I know 180 degrees will be here, so it's more than 180 degrees, and I know this one here would be 270. So we're looking for an answer between 180 and 270, so we know that's probably going to be correct. So this question is a simultaneous equations question, but it doesn't kind of look like the stereotypical simultaneous equation question, because we're given a context for this. However, if you imagine S represents the price of the gumbo sweets and C represents the price of the raspberry chocolates, what we can do is we can write these two pieces of information as this. So 2 lots of the S plus 5 lots of the C equals, and I'm just going to leave it in pence rather than pounds. I find pence a lot easier to work with. And then we can write the second one as 4 lots of the sweets plus 3 lots of the chocolates equals 220. So to do simultaneous equations, you need one of the coefficients to be the same. Looking at the S and the C, to get the C's the same, I'd need to times the top, all the numbers at the top by 3 and all the numbers on the bottom by 5 to get them both to 15. But if I look at the S, that's 2 and that's 4, so all I need to do is times everything in this first one by 2, and it would get these S's the same. So I'm going to times 5C by 2, and I'm going to times the 180 by 2, which would be 360. So to get rid of the S here, so I'm just going to try and make this a bit clearer about where we're looking now. So we're looking, I might do a little bit further up, we're looking at this part here. Now to make things a little bit clearer, when I subtract, which I'm going to do to get rid of the 4 S's, we're going to have a bit of a problem because everything's going to be negative. So sometimes it's a good idea just to copy down the first equation again. So 4s plus, which it's technically the second equation again. Oh, let me just rub that out. There we go. So 220. So I'm just copying it again so that when I subtract, which I will do, it can just make it a bit, well, make them positive, so make it a bit easier. Now at this stage we work downwards. So we're working downwards, we're looking at these two, and these two. And with simultaneous equations you're always working downwards. Now we need to get rid of the 4s, and that's the whole point of doing this with simultaneous equations. And there's a little rule that if the coefficients are positive, so they're both the same, or both of them are negative, so they're both the same means subtract. So just remember that, same coefficient, same sign, subtract. If the signs are different, so one's positive, one's negative, if they're different, the D in different is the D in add. So if they're different, you'd add them. But these are both the same, as we can see. So we're going to subtract them. So we're going to subtract all of these 3. So 4s take away 4s is nothing, which is great. We wanted to get rid of those. 10c take away 3c is 7c. And 360 take away 220 is going to be 140. So I'm going to get my lines in now, so I can solve this. And to get rid of this times 7 here, we're going to divide both sides by 7. So we've got c equals, and 14 divided by 7 is 2, so 140 divided by 7 is going to be 20. So c, the raspberry chocolate, is going to be 20 pence, or 0.20 pounds. Okay, but we need to work out what the price of the gumbo sweets are going to be. So what we do is we pick one of the original equations, and I'm trying to think what's going to be easiest. I like this one. So we're going to rewrite this, but instead of c, we're going to substitute in the 20. So it's going to be 2s, which we still don't know what s is, plus 5 times 20, which is 100, equals 180. Get my lines in. Okay, so first of all, we're going to get rid of that 100, so we're going to take away 100 both sides. So 2s equals 80, and then that's a times 2 there, so we've got to divide by 2 both sides. So s equals 80 divided by 2, which is 40. And so once it in pounds, that's going to be 0.40 pounds. Now you can check this by putting both of these numbers into the second equation and check that it works. So 4 times s, which would be 4 times 4, £1.60, plus 3 times c, which is going to be 60p, add the two together, and you get £2.20. So with this question, we can just rearrange it, because this is the same as 3 times x to the power of 5 times 7 times x to the power of 4. So we can rearrange it to put the numbers together. So 3 times 7 times 5, x to the power of 5 times x to the power of 4. Now these, this is just 21. 3 times 7 is 21. It's a dodgy looking 2. And this, when you times powers of the same base, you just add the powers together. So that's x to the power of 9. So my answer is 21 x to the power of 9. Okay, so for this question, understanding of the formula of a circle is critical. So formula of a circle is x squared plus y squared equals r squared. So it looks very, very similar to the equation given to us here. So if I rewrite the equation given to us, and instead of 4 I write 2 squared. Okay, and that's a perfect match for the equation of the circle. So we've got a circle with radius 2. So it's from the origin, which is here. Let's do this in red so it shows up. And it will pass through, it will have a radius of 2. Now I don't have a compass, but when you're doing this, do it with a compass, and you're going to see how rubbish I am at drawing circles. That wasn't bad, although I think it's just going to get worse. It's probably the least pathetic circle I've drawn, but use a compass in the exam. Measure out the radius on one of the axes, and then just draw a circle, and that's 4 marks. Okay, the easiest way to do this question is to use multipliers. A real common wrong answer to this is 80%, and I'm going to show you why that's not correct. So I'm going to work out the multipliers first. So an increase of 20% first. So I'm going to start off with 100%. I'm going to add 20%. That gives me 120%. Then I'm going to work that as a multiplier. So 120 divided by 100 equals 1.2. So if I times something by 1.2, it'll increase by 20%. Next, I'm going to do the 60%. So 100% plus the 60% equals 160%. And then I'm going to make that a multiplier by dividing it by 100, and I've got 1.6. So if I times something by 1.6, it will increase it by 60%. So what do I do? So we've got Billy here, and James collects 20% more. So I get Billy's and I times it by 1.2 to get James's. Then we've got Sam, who collects 60% more. So I get James's and I times it by 1.6 to get Sam's. So in total, I'm doing times 1.2 times 1.6. So let's just do that as one multiplier. So 1.2 times 1.6. So I get calculator, 1.2 times 1.6, and I get the answer of 1.92. Now 1.92 is the multiplier, but we've kind of got to work backwards to work out what percentage increase it is. So to work backwards, you just do the opposite. You times by 100, so divide by 100, so 192. Then instead of adding on 100%, we take away. So 192 take away 100 equals 92%. So it's actually an increase of 92%, not 80%. And it's because when Billy has 20% more than James, so Billy has a bigger amount. And then when 60% of it's calculated to work out what Sam has, that's a bigger amount for Billy. So you will expect it to be more than 80%. So 92% is probably correct answer, and through our working out, we've shown it is a correct answer. Okay, so we're asked to find the nth term of the sequence. So the first thing I need to do is work out what the sequence is going up in. So 9 to 22 will be 13. 22 to 41 would be 19. It's not the same. Okay, so that will be 25, and then this will be 31. Okay, so whenever you have a sequence that's not going up by the same amount, then the next step is to work out what the differences are going up in. The difference of the differences. Well, that's 6, and this one's 6, and this one's also 6. So if the difference of the differences is always the same, then you've got yourself a quadratic sequence. And the way of dealing with that is get the difference of the differences and always halve it. Okay, so we end up with 3. Now that 3 will go before an n squared. So we know our nth term will involve 3n squared, but we don't know what the rest of it is yet. So what we do is a little table, and we write in our sequence, which is 9, 22, 41, 66, and 97. And then we write down the sequence for 3n squared, which is going to be 1 squared times 3, okay, because n is 1 for the first term. So that's going to be 3. 2 squared is 4 times 3 is 12. N is 3 for the third term, so 3 squared is 9 times 3 is 27. N is 4 for the fourth term, so 4 squared 16 times 3 is going to be 48, and then 5 squared times 3 is going to be 75. Now what we want to do is take 3n squared out of our sequence. So if I call this sequence, we're going to do our sequence, and we're going to take away 3n squared from it. So basically what I'm doing is I'm going to do 9 take away 3, which is 6, 22 take away 12, which is 10, 41 take away 27, which is 14, and I'm just going to keep subtracting them. Now you might notice that we've got a linear sequence now. This linear sequence that's formed is going up in 4s. So each one is going up in 4s. And we find the nth term of this linear sequence. So we're going to have 4n, and then we're going to work out what the 0th one is. And I've not left myself very much room, and that's going to be 2. So our 0th term is going to be 2. So we know it's going to be 4n plus 2. So we put this bit here with this bit here, and that gives us our nth term of this quadratic sequence. So it's 3n squared plus 4n plus 2, and that's our answer. Now you can check this out by putting in 1 and putting in 2 and putting in 3 and seeing whether you do get 9, 22 and 41, which you will do. Now there are two things you always want to try and get rid of when you're rearranging equations or formulas. The first thing is fractions. So this fraction here we want to get rid of, and we do that by timesing both sides by y minus 5. So I'm going to write out the equation again just to make it a bit bigger. And we can imagine that there's brackets around the top and bottom of this, and that sometimes helps us to answer the question. I'm going to put my lines down. So the first thing I want to do is times both sides by that y minus 5. And you must do that. You can't access the numerator of the fraction otherwise. So this ends up with being x brackets y minus 5. And on the right hand side it's just the same numerator but without the denominator. Now I said there were two things you've got to get rid of. The first one's fractions, the second one is brackets. You've got to break them open. So we're going to times out these brackets. So we're going to have xy minus 5x. And the right hand side hasn't changed at all, it's just 10 minus 3y because we haven't done anything to both sides. So what I want to do is try and get all of the y terms to the left hand side and all of the other terms, so the x terms, the number terms, or whatever, on the right hand side. So I'm going to add 5x to both sides, but I'm also going to take away, add 3y to both sides as well. So I'm doing 2 in 1 here. So it's xy plus 3y. And on the right hand side we've got that 10 that hasn't moved plus 5x. Okay, when we have this situation where we've got the brackets gone away and everything is, all the y's on the left hand side, and y is what we're looking to do it in terms of, what we want to do is factorize it, so we've just got a single y. So y on the outside, x plus 3. Now I know I said I wanted to get rid of the brackets, but we need the brackets here to be able to get y on its own. And the last step here is we just divide both sides by the x plus 3. So we get y on its own. So we get y equals 10 plus 5x over x plus 3. So let's put that into our answer box. Now it can be either way around here. It could be 5x plus 10. That's absolutely fine. Still the right answer. Over x plus 3. Okay, so for this question you can see that there is a coefficient on the x squared, there's a number before the x squared. Now if it's 1 then we do this in a slightly different way. If it's not 1, which it isn't here, we need to look at these two numbers first. So we've got the 6 and the minus 5, and we just literally times those together, and that gives us minus 30. Now minus 30 becomes our number that we've got to make by multiplying two numbers together. But those two numbers also have to add to make 13. So if I just do some number pairs, I could have 1 and 30. Now, you know that 1 times 30 is positive 30, but I just look at it and go, well, if it was minus 1, that would make 29 when you add them together, and that's not going to get 13. If it's minus 30, that would make minus 29, so there's no way I can make the 13 with those two numbers. Next one I try is 2 and 15. This time, let's have a think. So if I put a minus before the 2 here, then minus 2 plus 15 is 13. So if I add those together, it does get to my 13, which is what I want. So these two numbers here, what we need to do with those is rewrite the question. So same as before, 6x squared. But this time, instead of plus 13x, I'm just going to write down minus 2x plus 15x. Now those are the two numbers that I found here and here. Then minus 5. So the only thing that's changed is I've split up that plus 13x here and decomposed it into minus 2x plus 15x, and that does add together to make plus 13x, so that's absolutely fine. But by doing that, I can then only look at this bit and this bit and factorize them separately. So I'm going to factorize the first green square. So let's have a look. 6 and 2, so we know we can divide out of 2, and they both have an x, so it's going to be 2x, and then that would make 3x minus 1. Let's check that. 2x times 3x is 6x squared. 2x times minus 1 is minus 2x. That works brilliantly. And then I can factorize the second green square, so 15x and minus 5. So there's going to be a plus 5 that I can divide out of both of those. And 15x divided by 5 is 3x. Minus 5 divided by 5 is minus 1. Now you'll notice, if you do this right, that you get the brackets the same. 3x minus 1, 3x minus 1. So what you need to do now is just grab the 2x and grab the plus 5 or whatever it says there and form a bracket with that. 2x plus 5. And then just copy down the repeating bracket. And that is fully factorized. So if I write that in, that is our answer. Now you can check this. If you've got time, you can expand this to check it's right. And when you expand it, you'll find out that it makes 6x squared plus 13x minus 5.
There are quite a few different approaches for this question. One thing we can do is try and find length AD by using the cosine rule. And the other approach, which I'm going to use, is I'm going to work out this angle here using the sine rule, and then work out this angle here, taking away from 180 degrees. Then when I've done that, then I can use the trigonometric area formula. So I'm going to work out the angle I marked first. So that is angle ADC. That's what I want to work out first. Now to do that, I'm going to call that, let's call it x. So it's a bit easier to write. So I'm going to use the sine rule, and that says that sine x over, so this is sine x, this is x here, so it's going to be over 8 equals sine 110 over 12. And the reason it has to be that way around is obviously sine matches up opposite angles and lengths, so it's going to be those two and those two. So first thing I'm going to do is just times both sides by 8. So it's going to be sine x equals 8 sine 110 over 12. And then what I'm going to do is inverse sine both sides. Scroll down a bit more. So x is going to be the inverse sine of 8 sine 110 over 12. So let's get my calculator. So inverse sine, fraction button, 8 sine 110, close the brackets, over 12, and then come out of the fraction, close the brackets. So that tells me that x is 38.789 blah blah blah. Now I want to keep the accuracy if I can, so I'm going to keep that in my calculator, and then what I'm going to do is add that to the 110 to work out what this angle here is, and I'm going to call that y. So what is this? ACD. So I'm going to tell the examiner that ACD I'm going to call as y, just to make it a bit easier. So y equals 180 take away 38.789 blah 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 plus 110. So I'm going to add 110 to that, then I'm going to type in 180 take away the answer. So that tells me that y is 31.2104 blah blah blah. Okay, so I've worked out what y is, which is good, because when you have a length, then an angle, then a length all together, then you can use the trigonometric area formula. And the formula is dead easy. It just says that area equals half AB sine big C. So we know the problem is actually we've got two triangles. We've got a triangle here, and then we've got an identical triangle here, and it is identical because the diagonal of a parallelogram cuts it in half exactly. So what we also need to do is then times this by 2. Now if we notice that the half and the times 2 will cancel, so it's just going to equal AB sine C. I've kept that number in my calculator, so I can use it. Was A and B. A and B are going to be 8 and 12. So it's going to be 8 times 12 times sine 31.2104 blah blah blah. So let's quickly use the calculator before it switches off. So I'm going to press sine answer, close bracket, times 12 times 8. And it says the answer is 49.7455 blah blah blah. Let's have a look and see the accuracy that I need. 1 decimal place. So let's have a look. That's going to be 49.7. Now, if you didn't keep the numbers in your calculator and you rounded them, make sure you round them to 4 or 5 decimal places. So I would probably round it at least to 3 decimal places, but you normally want to go a little bit further. You might find that if you rounded it, you might get a slightly different answer to mine. Now, that's why you must show you're working out, because if you got, say, 50 rounded to the nearest decimal place, or 49.8 or something, then if you can show you're working out, if you can show that you've done all of the steps and the reason why you got slightly off was because you rounded some of your working out, you might get full marks, but you would get at least all but 1 mark for the question. There are a few different ways of answering this question. The easiest way, especially for the way this question's set out, is to count the squares. So first of all, let's have a look and see what range we're doing. We're doing from 10, so from 10 to 40. So we need 2 things. We need to know, first of all, how many big squares, and we might as well count big squares there are between those two, 10 and 40, and we need to know how many there are in total. So let's just have a count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 11 tools. So that's going to be 22 in that rectangle. That's going to be 10 high. So that's going to be 10 big squares. 1, 2, 3, 4, 5, 6, 7. So that's going to be 14 big squares. And this little section here is 1, 2, 3, 4, 5, 6. So I can use a calculator if it's on the calculator paper. So let's add those together, and that's going to be 52. So there's 52 in total in that middle region. But we need to know how many big squares there are in total. So we go count the other ones. So 1, 2, so that's going to be 6, so that's going to be 12. And that's the same height, so that's also going to be 12 because it's 6 and 6. So we're going to add the 2 12s on. So there's 76 altogether. So total is 76. So it says it wants it to 2 decimal places. So it doesn't want it as a fraction, because as a fraction it's 52 over 76. So 52 divided by 76 is going to be 0.6842 blah blah blah. So that's going to be 0.68 to 2 decimal places. Now what you could have done is worked out the areas of each of the bars to get something that's maybe proportional to the frequency, and then done it that way. But if you can count the squares, it's just much easier and quicker. And sometimes you've got to sort of count half squares or little squares and find a way of doing that. But that's absolutely fine. When you're working with proportions, the actual amounts don't matter. Now the major rule with algebraic fractions, or fractions generally, is that the denominators must be the same, obviously at the bottom, that's where denominators are. They must be the same when you add or subtract. So we've got to make both of the denominators the same. So what I can simply do is times the left hand side by the right hand side's denominator, and the right hand side by the left hand side's denominator. Basically I'm going to times both top and bottom of this side by x, and then both top and bottom of the other side by 10 plus x. So 11 times x over this 10 plus x by x as well. Now I've kept that fraction the same because I've times top and bottom by the same thing. So it's the same fraction. That's important that you don't change the fraction. Then I'm going to times the 5 by the 10 plus x. And I'm going to times the x by the 10 plus x. Now, something I've done instinctively, and a lot of people make mistakes on, is I put brackets around the expression 10 plus x. And if you don't do that, you will end up, say here, just timesing the x by the 10 and not timesing the x by the x on the right hand side. So always put expressions that are in fractions in brackets. Okay, so now the bottoms are the same, we can just simply add the tops, and I'm going to expand that top bit. So 5 times 10, which is 50, 5 times x, which is 5x. I'm going to expand the bottom, but you don't need to. So the bottom will stay as x brackets 10 plus x. The bottom, in fact, let's do that step first to make it really clear. Okay. So, and I'll put an equals there. Okay, now we've got 11x plus 5x, which is 16x plus 50, over, and I'll expand the bottom one, so it's 10x plus x squared. So my answer is 16x plus 50, and you normally do by powers of x, so I'm going to do x squared plus 10x. Now, unless it explicitly tells you otherwise, you don't need to expand brackets, so you could leave the bottom one in brackets, but I needed to expand the top one because I was adding the 11x on. So if it's literally like that, I wouldn't have needed to expand it. I could have just left it in brackets, but read the question because it might ask you to. Right, so this question looks a bit daunting, but if we break it down, it is kind of simple as long as you can kind of view things in 3D. There is a length that we need before we start answering what the length of AM is, and that's this length here. Now I'm going to call this length x. I'm going to use Pythagoras to work out what x is, and then we're going to work out what y is, which I'm going to call the height. In fact, why don't we call it h for height? That's probably more sensible. By using the value of x, or using half the value of x, using that 5 up the side, and using Pythagoras to work out what h is. Okay, so I'm going to draw out the two right angle triangles I'm using. Triangle DEB, first of all, to work out what x is. So that's DEB, and we call this one x, this one is 4 centimeters, and this one's 3 centimeters, and then we're going to work out what the height is. So it's a at the top, is it? Yeah. So it's a m d. Now we know this one at the bottom is going to be half of x, and we know at the top it's 5 centimeters, and this one we just go call h. Okay, so we're going to work out what x is first, and if you don't know how to use Pythagoras, there's loads of stuff on the site on how to do that. Now it's a 3, 4, 5 triangle actually, so let's do this all anyway. 9 plus 16, root 25, and that's just actually going to be 5. I would leave it as a root if it doesn't work exactly, so I'd leave it as a square root. Okay, so we know what this one's going to be. It's going to be x divided by 2, which is 2.5. Okay, so to work out what h is, I'm going to do the hypotenuse squared minus that length that we've just found out squared, and just get my calculator. Root 25 take away 2.5 squared, and it's 4.330 blah blah blah. So it's 2 decimal places, it's 4.33, and it's probably sensible to check that makes sense. Have a look at the numbers we've got in the question. Imagine a 3 by 4 by 5 rectangular based pyramid. Does that kind of make sense? And to me, yeah, that kind of makes sense. It's less than the 5 here, and since 5 is the hypotenuse on that triangle, it needs to be less than that. So yeah, it kind of makes sense. Okay, so this question's all about iteration, and basically an iterative formula or iteration formula is one that gets you closer and closer to a solution. It will never quite get there, but it gets you closer and closer to a solution, or it gets you further and further away, and some of them do. So you'll always be given an iteration formula if you're asked to do iteration. So we're given one here. To get to the next number, we do 13 minus root x. So that tells us how to get to the next one, the closer answer, and normally these will get closer and closer, otherwise it's very silly to do it because you'll just end up with very big numbers. So it tells us here to start at 2. It says, right, start at 2 and then work from there. And the iteration formula, or iterative formula, tells us how to get to the next one. Now, have your calculator out, because it's a calculator question. I'm going to ask you to do something weird. What you're going to do is you're going to press 2 and then equals. Now, it equals 2, so the calculator just says 2. But this next step is actually pretty clever with these calculators. You can type in 13 minus square root answer, and on calculators it's normally ANS, or some of them they write the word answer. Now when you press equals, it will give us the answer, so that's great. So you might need to press S to D to make it a decimal. So we write down the answer, 11.5857 blah blah blah. But the clever bit is, if you press equals again, it will give you the next answer. So this time 9.596 blah blah blah. And just keep pressing equals. 9.9022 blah 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 blah. Equals again. 9.85321 blah blah blah. Equals again. 9.86, it's getting close, you can see. Equals again. Now you might be wondering where we stop. Well, it says it wants 2 decimal places, so we stop when we get the same rounding. Now you can see here that both of the last 2 would round to 9.86, so we could stop now, but I'm just going to go a little bit further to see what happens. And you can see again, every time you press equals, and you can just keep pressing equals, it will just get closer and closer to a number. Now, it might appear on the calculator that it stays at the same number at a point, but actually the number that's changing is so far down the stack, or so far down the decimal places, that you just can't see it anymore when you press equals enough. So my answer will be 9.86, but like a lot of questions on the exam, it's the working out that gives you the mark. So you have to show all the stages, your x1, your x2, your x3, x4, x5, x6, and then we did the next 7 just for the heck of it. Okay, to answer this question you need to understand the sine wave. And the sine wave starts at 0 and then goes up to 1 at 90, goes back to 0 at 180, down to -1 at 270, and then back up to 0 at 360. Now what's happening here is we're taking away 30 before we put it into sine. So at this point here, sine thinks we're at 0 because that point there is 30. So we're going to do 30 take away 30, which is 0. Sine thinks we're at 0, which it will spit out the 0 as the answer. Similarly, at this point here, it's 120. We're going to take away 30, which is 90, so sine thinks we're at 90. So all the way along here, sine thinks that we're kind of 30 to the left. And so it will be very similar to a sine wave, but it will just have moved to the right. I'm rubbish at drawing these. That was really poor because that went up too quickly there. And this is kind of a stretched out one. So we're going to go up to here, then we're going to go back down to here, Now notice that it doesn't start at 0, it starts somewhere, and I've estimated here somewhere there, and it doesn't end at 0 because it will go back to 0 at 390, because then we'll do 390 take away 30, which is 360, so it doesn't end at 0. So the rule is that if you minus something within a function, then it moves right by that amount, and it's counterintuitive. You'd think if you take away 30 it will move left 30, but it goes the other way, and hopefully I've explained why.
Okay, so this doesn't seem like the easiest questions because there's 3 shapes going on, there's no numbers in it at all, and we're asked to find a formula. So the first place I'd start is working out, well, first of all, what are the formulas we'll need? Well, let's have a look. So we've got a hemisphere. And some of these formulas you will be given. So a hemisphere is a volume of a sphere and then halved. So instead of 4 over 3, I can just say 2 over 3, which is half of 4 over 3, pi r cubed. The cone that we've got is going to be 1/3 pi r squared h. And then the cylinder we have is the area of the circle times the height. Okay, now we need to find out what the bits are. So for the hemisphere we just need r. Well, that's quite simple because r is just going to be x. It's the radius of the hemisphere. Okay, now what's more difficult is to work out the height of the cone. Well, if the radius across to the right is x, the radius of the circle up is also going to be x. So we know the height of the cone is going to be 4x because one of those x's is used on the hemisphere. We know the radius of the cone is going to be x because it's stated at the top. So let's keep going. The radius of the cylinder is going to be 10x, and the height is just labelled as h. So that's nice and simple. Okay, now let's have a look at what this question's saying. It's saying that this thing here is going to be melted down and is going to be used to create this. So that's just saying that the volumes are going to be the same. So if I add the volume of the hemisphere to the volume of the cone, it should equal the volume of the cylinder. Okay, so we know that a hemisphere plus the cone volume, and I should write volume here, show the examiner that I'm working with volumes, equals the volume of, I don't know why I wrote an S, my goodness, C for cylinder. Wow. Tell my maths teacher, right, cylinder, there we go. So hemisphere is 2/3 pi, and we said that x was the radius, so x cubed. Brilliant. So plus the cone. Now, what did we say the height of the cone was? We said the height of the cone was 4x. So it's going to be 1/3 pi x squared, because the radius is x, and is it 4x? Let's double check that. Always double check. Yeah, it is. Okay. So the cylinder, and I'm going to leave that up so I can see it, is pi, and what's the r? So pi times 10x squared, and all of that squared, because all of that is r, times the height, so times h. Okay, so this is the formula we've got to work with. I'll put my lines down. Okay, so what we got? Let's sort out the timeses first, and let's tidy this up. So that hasn't got any timeses in it. This we're timesing it by 4, so it's going to be 4/3 pi, and I'm timesing it by x, so that's going to be x cubed. this one I'm doing the 10x squared, so I need to square the 10 and the x, so it's going to be 100, and let's do the pi next, pi, and it's going to be x squared h. Okay, now if you notice on the left hand side, these two here are the same, they're both pi x cubed, so we can just add them together. So it's going to be 2/3 plus 4/3, so that's going to be 6/3, or just 2, so it's going to be 2 pi x cubed equals 100 pi x squared h. Brilliant. Okay, now let's just check to see what it wants. It wants a formula of h in terms of x, so it wants h equals. Okay, so first thing I need to do, well, let's have a look. What's easy to do? Well, what's easy to do is just divide both sides by pi. Let's get rid of the pi's. So 2x cubed equals 100 x squared h. Now we want h on its own, so we're getting close. We need to divide by the x squared first to get h on its own. So I'm going to divide by x squared, so we get 2x equals 100 h. So we can already see we're really close. So to get h on its own, we need to divide both sides by 100, and that's going to be 2x over 100 equals h, or h equals, and we can cancel the 2 and the 100, we can divide them both by 2, equals x over 50. So our answer is h equals x over 50.
Okay, so this question seems really easy at first, but there's a bit of a gotcha in it. So the first thing I'm going to do is just calculate, oh, click the wrong one. I'm just going to calculate the total length of this line here, because I think that will help me for later on. So that's going to be 35 centimetres, and the other one will be x plus 7, so that's not going to be helpful writing that down. Okay, so we've got two similar triangles, which means one's a direct enlargement of the other one. And so this seems quite a simple task relatively. So that 5 there grows to 35. Okay, and to do that we do, well, to work out the scale factor, so scale factor, so the 5 to the 35. The scale factor is going to be 35 divided by 5, which is 7. So scale factor is 7. So therefore this one here, to go to the larger length, which I can highlight, and just kind of, there's blue here, we're going to times that also by 7. So if this times is by 7, then this one will times by 7, so that will be 49. So x plus 7, the whole length would be 49. So to find x, it's just going to be 7 less than that, so it's just going to be 42. So x is definitely looking like it's 42. However, it does say there's two possible solutions. One of the flaws that we've made is that we've assumed that the 5 corresponds with the 35, that this length here corresponds with the total length here. However, that's an assumption that we've made because it kind of looks like it does. And we're kind of used to questions where it does, because normally we know that these two here are parallel, and therefore it definitely would. But there's nothing in the question that says these two are parallel. So it could be that this 7 centimeters here is the one that corresponds with the 35 centimeters here. So we've got to then run the figures again. So it could be that the 7 corresponds with the 35 centimeters. So scale factor then would be 35 divided by 7, which is 5. So if the scale factor is 5, then we're going to look at this top one here, the 5 centimeters here, and times that by 5 to get to the x plus 7. So it'd be x plus 7 equals 5 times 5, which is 25. And then take away the 7 both sides, which would be 18. It's very, very difficult to get your head around that because it's so convincing that these two lines are parallel, but they're definitely not. And the hint in the question, in this one anyway, is that it's saying that the diagram is not drawn accurately. And in the exam, if they ask a question like this, you'll notice that the two lines here are going to be subtly different sort of slants on them so that it's not too misleading. But yeah, very, very difficult to spot, and sometimes in the exam you'll have questions like that. You just need to try and think through what assumptions have you made and are you right to make those assumptions.
I hope you enjoyed that video. Don't forget you can go to our website onmaths.com, which the link will come up there now, and to do the paper online, or to check out our other stuff. We've got topic busters for all of the topics that can come up. Don't forget that this is only a practice paper. We call it a prediction because what we've done is we've cut out the stuff that we feel has come up in paper 1 and 2, and so leaving a few topics that we select which ones the exam board generally goes for in paper 3 on the calculator or paper. So it's only a bit of practice. Please don't rely fully on this paper at all, and just make sure you do normal revision as well as this video. If you've liked this video, please click like. If you really like it and want to see more from us, especially in the next few days, please click subscribe. Thank you very much.